Hello, we're going to be doing the 2023 Junior Maths Challenge, which was on the 26th of April 2023. You don't lose marks in this one, which is great. 60 minutes. I'm going to try and do it as fast as I can, trying to get full marks. I don't know if I will get full marks. Solutions aren't out, I don't think, but I'm going to see how well I can do. Camera angle's a bit jarring, but that's completely fine. So I'm just going to get started and see what happens. Haven't seen it before. No calculator. This is generally for a 7 and 8, so I'm hoping for a quick one. Okay, let's get started. Okay, starting off with 3202 minus 2023. Okay, this is one of those interesting ones, but I'm going to add one to the top one, and it will make my life easier, and then I'll take away one for the result. Because you can actually do 3203 minus 2023, which I can be easier. 0, 1, 8, 1, 1, 1180, but actually then it's 1179. Oh god, imagine if I got that wrong straight away. Okay, that was probably a bit slow anyway. So, next. How many of the following 5 options are factors of 20? Oh, that's really funny. So this is, and this is, and so the answer is 4. That's a good chat. 1, 2, 3, 4. Okay, this top thing adds to 15, divided by, and then it's 16, 16, 32, 40, 15 over 40. Definitely a cooler way to do that, but we're speedrunning, so it's fine. 3 eighths. I wonder what the cool thing is there. Maybe you can factorize something, but whatever. When one of these is the largest 2-digit positive integer that's divisible by the product of its digits. Okay, this is, oh, by the product of its digits. 2 times 4 is 8, yeah? 3 times, oh yeah, that is. 7 times, oh yeah, that is. 9 times 6, wait, 9 times 6 is 54. Okay, it's not that, but that is. Okay, how interesting is that? Question 5, record for trying 90.65 seconds, which is by Jumpy. What's it? Approximate average speed. 100 divided by 20. 5 meters per second. Mate, these papers are easy. Maybe not, just the beginning. When this different prime number square, the 8 circles contain 8 different primes, 1 and each of the 4 sides has a total of 43. Okay, so that's 36, which... Okay, you can do this a different way, but whatever. Because I think it's... Let's just do it the quick way. 36, that's a 7, and then it has to be 43. Actually, let's try 17, 30, 8 different primes. Oh no, no 17 there. How about 17 here? That makes 40, that's 3, 32, 11, 24, 19. Okay, cool. 30, 40, 57. I think there was a different way you could do that. Like, you know that all together it has to add up to a certain amount. But once again, we're speedrunning. Generally, the largest 2-digit multiple of 2. So that's 98. Smallest 3-digit multiple of 3. That's 102. So, digit sum, multiple of 3. Difference is 4. How many of these 6 numbers are prime? Okay, this is 1, so it's not. This is 5, so it is. Yeah, this is 4 plus 9, 13, so it is. This is 3 plus 16, 9 plus 16, which is 25, which is not. 16 plus 25, which is 41, which is, oh my god, is 41 prime? Or is it 17 times 3? I think it's prime. 25 add 36. 25 add 36 is 61. 61 prime. Is it divided by 7, 17, 9, 13? 13 times 5 is 65. No, okay, 1, 2, 3, 4. 4 of them. Isosceles. Okay, so 2x plus 8 equals 3x minus 20. X equals 28. So then these 2x is 56, add 8 is 64. So that's also 64. And that makes 128. So we have 4y minus 8 equals 180 minus 128, which is 52. 4y equals 60, y equals 15. Your classic. That was fun. Okay. I did that a bit faster. How are we going to write? X, 28. 28 times 2. Oh no. 2 times 28 is 56. Add 8 is 64. 64. Yeah, I'm sure it's fine. In this diagram, the perimeter of the shape is 60. What's the area? Okay, well, this is 12. And A and 8 plus A. So we have 18 times 2, which is 36. Plus 2 lots of 8 plus A, which gives you 60. So minus 36, that's 24. Divided by 2 is 12. 8 plus A is 12. A equals 4. This length is 4. This length is 4. So the area is 18 times 12. Yeah, so the whole thing, 18 times 12, minus 4 times 6. So how can we do this in a nice way? Okay, 36 times 6 minus 4 times 6, which is 32 times 6. 32 times 6, 6 times 2 is 12, 6 and 8, that's a 19, that's 192. Woohoo! Let's do some rubbing out. Okay, we're flying, but we're not flying, I don't know. To save money, Scrooge reusing tea bags. Tries to use it too such to make a decent, wait. Whoa, new box of 120 tea bags. Okay, so first round he can make 120. Then he can make 60. Then he can make 30. Then he can make 15. Okay, so they can use once. They can use twice. Then they can be used 3 times. So they used once. And then he needs 2 of them. And then he can do it again, and he needs that, and then they're put on a cup of tea. So he can do 210. Okay, quite nice. One afternoon, Brian Snail went for a sled at constant speed, 150. Okay, so it took him 20 minutes to do 60 centimeters. So he's doing in 10 minutes, no, in 1 minute, he's doing 3 centimeters. So if we go back 50 centimeters, so 150 centimeters, we go back 150, which is 50 minutes. It takes 50 minutes to 150 centimeters. So we go back 50 minutes, he started at 1 p.m. 4 cone rectangles arranged as shown to form an inner square of area 20. Okay, so X, A, whole thing's X plus A. Okay, this is definitely not meant to be an algebra problem, but that's fine. We've got X squared equals to 20. We've got X plus A all squared, because the little bit's A, is equal to 64. So, I mean, I could square root this. X plus A equals 8. Oh, yeah, I can just do that. X plus A equals 8. And the perimeter is just 2x, 2 lots of X plus A, plus 2A, right? So it's 2x plus 4a. Wait. What am I doing? I mean, I could all just work this out, like x squared plus 2ax plus a squared equals to 64. X squared is 20, so 2ax plus a squared equals to 44. But That seems a bit horrible, doesn't it? The area, okay, the perimeter is, we're looking for 2x, 2 lots of x plus a, that would be the lengths, plus 2a, which is 2x plus 4a. What am I doing wrong here? Something silly is happening here. Okay, 4 corner rectangle range to form an inner square of area 20. Okay, I also know that the difference between the, so 4ax, so 4 of these rectangles have to be the difference between bigger and smaller. So 4ax has to equal to 44. That also equals to this. What am I doing here? 2ax plus, this is 2ax equals a squared. What am I doing? 2x equals a? I mean, that's useful, because then this is just 2x plus 2, but I'm doing square root of 20. What? Okay, I've done something wrong, but 2x plus 2x is a, plus 8x, so 10x is the perimeter, but x is root 20. So how on earth have I got 10 root 20? That's just wrong. 10 root 20 is root 2000. Okay, what on earth has happened there? Let's try it again. Okay, so what am I saying? I'm saying 4 corner rectangles are arranged as shown to form an inner square of area 20. So a times a squared is 20. Outer square of area 64. So a plus b squared equals to 64. We also know that, well, if we just, that's a squared plus b squared plus 2ab equals 64. And what we're trying to find, the perimeter of one of the 4 rectangles. What's happening here? The perimeter is a plus b times a plus a plus b. So the perimeter is a plus b, 2 lots of that, plus another 2 lots of b. So the perimeter is 2a plus 4b. I mean, what? What? Okay, I've spent too long on it. We come back to 13. That is weird. I really don't know what's going to happen there. Okay, in this addition, single digits. Well, to get to 9, or to get to 7, we can only do that with 27. So that's 9, 9, and 9. Okay, that's a bit big. So x is 9. That's 9, and that's 9. And then we're carrying a 2. So 2 plus 9 is 9. To get to 9, these either need to be 5, 5, or 0, 0. So if they're 5, they need to be 5s. So 9. So x plus y is 14. Fun. My train was scheduled at 7:28. Arrived then. Okay, so it was meant to take 12 plus 25. It was meant to take 37 minutes, but it actually took 74 minutes, and it was 4 minutes late, so 78 minutes. So 78 minutes after this is an hour, which is 18:48 plus 18 minutes, which is 19. How many am I adding? 18 minutes. 19:06. Fun. Decided to make a 4 non-trivial with the following properties. Oh, let's let's rub this out. The first two digits, last two digits, each make up a 2-digit number, which is a multiple of 11. So 4 digits. Sum of all the digits is a multiple of 11. First 2 digits, the last 2 digits is a multiple of 11. So if I have 9999, that's the biggest number it could be, and that's 1836. So we're looking to make 33. So if I have 99 and I want to make 33, I can't do that because I can't take away 3. I'm losing multiples of 2 each time. So can I get to 22? I can. I'm losing 14, so I just take away 7 from each. So 9922. That works because 11, 11, 22. Oh, so these digits have to add to 11. Okay, so the digits need to add to 11. So 8, 8, 3, 3. That works. 7, 7, 4, 4. 6, 6, 5, 5. And oh, but then also this is a nice problem because you can also do it the other way around. So 1, 2, 3, 4, and the other way around, which is 8. Oh, that's a nice problem. Two numbers are such that that's what's the largest operation. So Q is a fraction bigger than P. So Q minus P will give me something bigger than 0. P minus Q, well, P is smaller than Q, so when you take it away, that's smaller than 0. So get rid of this guy. If I find the average of them, that's going to be right in the middle. Huh. 0, 1, P, Q. It's always going to be in the middle of them. So the largest it could be is if they were both up here, and then it would be way up here. Okay. P over Q. So a fraction, so A over B divided by a fraction bigger than it, so C over D, would give me AD over BC. Where? Let's try with numbers. What am I doing? Let's just try with numbers. What if it was an big divided by small gives me big. We want to, with division, we want to, if I want a big answer, I want a big divided by a small. So this, I want this. I want a big divided by a small. Big divided by a small, not that. This is going to be less than 1. This is going to be less than 1. This is going to be bigger than, isn't it? Because let's say 2/3 divided by a half is 4 over 3. Yes, that was hard, but it's that one. What's the sum of the 4 marked angles? What? Okay, let's call it A, B. I mean, they all look exactly the same, but that's also D. These look interesting. So that's 180 minus A. That's 180 minus D. That is B. That is 180 minus B. That is 180 minus C. This over here, let's just change colour. This, oh my god, that's much too big. This, well, we've got 180 minus B plus 180 minus C equals 180. Oh no, plus X. So we've got wait, but then we want to take that away from 180. So these two add to this. This guy. That guy is the same as these two. This plus this, 180. This plus this, 180. So this plus this plus this. This equals those two. So that is 360 minus B minus C. And now I think we have enough information, because in this triangle, we've got 180 minus A plus 180 minus D plus 360 minus B minus C equals to 180. Hooey. So if I put all the A, I get A plus B plus C plus D equals, and then on this side, these 180s cancel, I have 540. 1, 2, 3, 4. That's interesting. There's something cleverer going on than I did, but I think it's 540. In a foot match, Rangers beat Rovers 5-4. The only time we were ahead was after they scored the final goal. Okay. The only time Rangers were ahead was after they scored the final goal. The only time they were ahead was after they scored the final goal. So, okay. So at half time, it could have been, so Rangers, Rovers. It could have been 0-0. It could have been 0-1. Could have been 0-2. Could have been 0-3. Could have been 0-4. Could have also been 1-1, 2-2, 3-3, 4-4. Could have also been 1-2, 1-3, 1-4. Could have also been 2-3, 2-4. Could have also been 3-4. Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Cool. Cool. Carnage games all around. Okay, next. In each cell, the cross number is a single digit, which can be the sum of the 4 digits. So across is a cube, down is a prime, 2 across is a square. So for it to be a square, 2-digit squares are 16, 25, 36, 49. I'm only going to want an odd one because one down is a... Oh, no. Oh, okay. 64 and 81. Now, all of these, we need this digit to be odd because its second digit, because one down is a prime, its second digit must be odd. So we basically only have 36. So this can either be 3 or 1. And this is always a 6. That's always a 6, because it's either 36 or 16. 1 down to be a cube. Cubes, 81's a cube. Oh yeah, my cubes are only 3 cubed. Oh no, 3 cubed is 27. 4 cubed is 64. Oh, it's a cross. 27 or 64. What's 1 down? A prime. 63 is not prime, but 23 is prime. 61 is. Oh, wait. 61 not prime because that messes up something from earlier. Because look, it looks like we've got this. That could be 36. 1 down could be, 1 across could be 27. That's an option because 23 is prime. Oh, which of these could be the sum? Okay, so we add those together, that's 18. Okay, but that means there's the other option. So that would work. There's also the option where this is 61. And then this is 7 plus 7, 14, 20. Oh, wait, what? 1 down is a prime, 61. That might not be a prime. 2 across is a square. Oh, 1 across is a cube. Oh, that's a 4. 10, 17. Okay, cool. I would hope 61's prime. Eleanor's elephant in 4 has 4 times elephant, twice as many grey as pygmy. Oh, wow, okay. Grey, pygmy, white. Okay, what? Twice as many grey as pygmy, so 2 pygmy equals grey. We're looking for G plus P plus W, a classic simultaneous equation. 2P equals G, 3 times as many white as grey. So 3G equals W. 4 times as many pink as white. Pink, and P plus 20 equals W. I think we can make these all into, I mean, if I add these together, I mean, don't overthink it. This is 8 to 2, and then this is 8. This is 8 to 24. And then, okay, so, I mean, the ratio, 8, 2 thing, 12, because 24 is the same as 2, like this. But also, P plus 20 is W. So the 6 missing parts between these two ratios have to equal to 20. So 2 of them, and then all together we've got 22. Ooh, no, something's gone wrong. Twice as many grey elephants as pygmy. Well, then that can't be a 2. Ooh, Kev. Okay, something's going wrong here that shouldn't be. Okay, we're looking for a number that's 432. 4 times 3, so all in terms of 12. Twice as many grey elephants. So the ratio of G to P is 2 to 1. P to W, no, 3 times as many white as grey. So for every 3 white, 3 to 1. 4 times as many pygmy as white. 4 to 1. Okay, let's make it all to 12. So times this by 6. So that's 6 to 2. And then, oh no, it's not. It's, wow, it's really not. Times by 6. 12 to 6. This is 6 to, oh no, we need to time that by 12. Oh my word. 12 to 36. And we need to times this by 3. Wait, what am I doing? What am I absolutely doing? Okay, let's just blend these two. 2 to 6. 6 to 24. So it's 2 to 24 to 6. Okay, and now the difference between P and W is 20. So those 18 parts is equal to 20 elephants. And altogether we've got 32 parts. What? 20 more white elephants than pygmy elephants. Wait, how does that make sense? I've got my ratios wrong again. What am I trying to do here? Okay, let's try again. There are twice as many grey as pygmy, so it's 2 to 1. There are 3 times as many white as grey, so white to grey is 3 to 1. 4 times as many pink as white, so 12 to 3. And that 12 is to 24. There we go. Oh my word. No, wait, what? 4 times as many pink as white. Oh my god, pink is a colour. I've been looking at pink and pygmy as if they're the same thing. There's 4 types of elephant. Read the question, you're speedrunning. Grey, white, pink, pygmy. Okay, so there are twice as many grey elephants as pygmy elephants. 2 to 1. There are 3 times as many white elephants as grey elephants. And 4 times as many pink elephants as white elephants. 4 times as many pink as white. Great. 20 more white than pygmy. So that, okay, 5 parts is 20. 1 part is 4. Thank the Lord. There we go. How many elephants? 33 times 4 is 66 times 2, which is 132. Wowzers. Wow. Read the question. So many minutes wasted. Okay, next. Oh, I still got the hard questions left. God, this isn't going well. Okay. 22 pods of integers are placed in this row one cell, so the product is shown. What number should be placed over there? Okay. We're looking at factors. So 36 is 6, 3. 36 is either 1 times 2, no, 139, 139, or 3, no, it's not 139, it's 6 times 9, 6 times 9, 3 times 2 times 9, or it's not 6 times 9, it's 9 times 4. What a long day we've had here. It's 9 times 4, so we could have... Let's deal with the 5s. This has to be a 5. Let's deal with the 5s. Let's chill out. And then this is 36, which means it has to be 9 and 4. So that's 9 and that's 4. I'm overcomplicating things. This has to be 2 and 1. If this is 2, then this will be 18. So that's 2 and 1. To get to 36, it's... Wait, no, that's wrong. Okay, let's try again. Okay, let's try again. That has to be a 5. 5 times 21 gets to 105, so it's 3 and 7. 7 goes here, 3 goes here. These go to 12. These have to go to 8, so they can be 8 and 1, 4 and 2. Can't be 8 here. That does go into 8. That does go into 1, because you could have 1, 2, 9, so we need 4, 8 and 1, or 4 and 2. If that's a 2, that would get me to 96. You can't get that. That could not be a 2 either, so it has to be 8 and 1. So 1 and 8. This has to be 9 and 2. Could go either way. That can't be a 9. That's a 2. That's a 6. That's a 9. That's whatever's left, which I think is a 4. We're done. That's a 6. Okay. PQRST has center O. What are the sides of angles TGO? The 6 angles at O are equal. So, wait, we're getting equilateral triangles? No, we're not. Okay. In a pentagon, we've got 180 times 3, which is 540, divided by 5 is 108. So this is half of 108, which is 54. This is also 54. Is it an isosceles triangle? Don't know. This is 108. This is 108. This is 108. All together, all these angles, including the ones in the middle. Wait, what? 6 angles at O are equal, so they're all 60. TG. Oh, they're all 60. That's pretty chill. I thought we had to find them. That's 60. That's 60. 54. That's 114. 114. Oh no, so we subtract that away from 180. So 54 and 60 and 60 and 108 and 60 and 90. So 168 plus 90 is 258. 258. So that's 102. So TGO is just 102. It's just 78. Okay, that was not that bad. Beatrice was born in this century. On her birth this year, her age was equal to the sum of her digits of the year Beatrice was born in this century. On her birth this year, her age was equal to the sum of the digits of the year in which she was born. Okay, so her age is 10. Her age is some two-digit number, 10a plus b. That's her age. It's the sum of the digits of the year she was born. And it's this century. So she was born between 2000 and 2100. Oh no, she was born this century already. So between 2000 and 2023. Okay, on her birth year, her age was equal to the sum of the digits of the year she was born. If it was 2 and 4, 2001, I mean, I could do this the long way. I could just go through each one. 27. Okay, if we go for 2009, 2009, she's 11. When she's 22, 11 years later, twice the sum of the digits of that year. So if that 22. So here she's 22. And what age on her birthday? Twice the sum of the digits. Here, 4 plus, here she'll be 26. Here she'll be 30. Here she'll be 34. And here she'll be 38. Which means 22 years ago was 2005. Birthday this year. Wait, on her birthday this year in 2023? Do they literally just mean 2023? So if we add those up, that gets to 7. It was equal to the sum of the digits of the year in which she was born. So in 2023, she is the same age as the sum of the digits of when she was born. I find it's hard to process. On her birthday this year, that's 2023. Her age will be equal to the sum of the digits. So for example, if she was born in 2009, she'd have to be 11. 2010, that wouldn't work. 2015. Okay, in 2015, if she was born in 2015, then when she's 8 in 2023. So she's 8 here. She's 8 here. So if she's 8 in 2023, in which of these years will her age on her birthday be twice the sum of the digits? Okay, she was born in 2015. Because, but couldn't it also be 2026? No, she can't be born in the past. But she could have been born in 2006. No. If she was in 2014, that adds to 7. So she can't be. Should be 9, doesn't it? I think it has to be this. Okay. So she was born in 2015. So here. Wait, what am I doing? 2 plus 3 plus 1 is 6 times 2 is 12. 2 plus 3 plus 3 is 8. That's 16. Here, that's 10. She's 8 in 2023. She was born in 2015. On that year, in 2023, her age, which is 8, is equal to the sum of the digits of the year in which she was born, 2015. Correct. In which of these years will her age on her birthday be twice the sum of the digits that year? So in 2027, her age will be 22. Which is true, because she was born in 2015. Ah! Okay. Granny gave away her entire collection of antique spoons to 3 people. Her daughter received 8 more than a third of her total. Okay, daughter, son, neighbour. Her daughter received 8 more than a third. So the total is D plus S plus N. So she 8 plus D plus S plus N over 3. 8 more than a third of what was then left. So this is 8 plus 2/3 of 8 plus D plus S plus N over 3. No. Wait. Let's slow down. She receives 8 more than so this is a third. She receives 8 more. Then her son receives 8 more than a third of what was then left. So 8 plus, and then this minus this. So D plus S plus N. 8 more than a third of what was left. So what was left was this. Like that. That's what was left. No. Which is 2/3 lots of D plus S plus N minus 8. Okay. And then he receives 8 more than that. 8 more than a third of what was then left. So 8 more than a third of that. And then neighbour receives what's 8 more than a third of what was then left. I feel like I could just try and error this. If it was 14, I mean, it needs to be a multiple of 3, doesn't it? Oh no, some of the digits and the number of the spoons. Ooh, okay. Okay, so the neighbour receives 8 more than a third of what was left, which is D plus S plus N minus these two added together. Okay, let's make this easier. Let's call it X. Okay, she gets 8 minus X over 3. Okay. Then what's left over is X minus 8 minus X over 3, which is 2X over 3 minus 8. Okay, and this person gets a third of that. 8 more than a third, so 8 plus a third of that. So 8 plus 2x over 9 minus 8 over 3. Okay, horrible. And this person receives 8 more than a third of what was then left. So 8 plus x minus this, no. everything that's left. So these two added up. But it's a third of it. So 8x minus 8 minus x over 3 minus 8 plus 2x over 9 minus 8 over 3. Oof. But then those added up equal to x. Oh God, I've done this in a terrible way. 8 plus x over 3 minus, no. Oh, we're not even going to do it in an hour. So sad. 8 plus a third of x minus 8 plus x over 3 minus 8 minus 2x over 9 plus 8 over 3. 8 plus, okay, this is 4x over 3 minus 4x over 3 minus 2x over 9. So that's times that by 3, that's 12x over 9, 10x over 9. So that's a third of 10x over 9 minus 16 plus 8 over 3. So that's minus 48 over 3 plus 8 over 3, which is minus 40 over 3. Oh, I hope this is right. I need to... This is a horrible way of doing this. I'm not very good at finding tricks in this one. Okay, so this is 8. And the whole, all together, we're going to need to add these all together. That's going to equal to x. And then we're going to solve that. Oh, I'm just doing this in such a bad way. Just like we can, I feel like we can collect the 8s. I don't know. What number is this? I hope it's 40. Is it 40? I think so. Okay, we have 8 minus x over 3 plus 24, 16 over 3, 16 over 3 plus 2x over 9 plus 8 plus 10x over 27 minus 40 over 9. This equals to x. Let's solve for x. I've done this terribly. I'm sorry. Okay. So we've got, let's make it all 27. So, and all over 3, all over 9. So 72 over 9 minus 9x over 27 plus 48 over 9 plus 6x over 27 plus 72 over 9 plus 10x over 27. This is terrible. Oh God, this is terrible. Okay, if we times everything. Okay, let's 16. We've got 7x over 27. That's horrendous on this side. 7x over 27. Because yeah. And here we've got 72, 48, that's 50, 120, 192, 152. This is the worst way I've ever seen anyone answering this question. It's just absolutely terrible. Because then when I take this on that side, I get 152 over 9. This is going to be wrong. This is just going to be wrong. 20x over 7. This is just wrong. There's no way this is true. I've had an absolute nightmare. Okay, so daughter, son, neighbor. The daughter gets 8 plus x over 3. The son gets 8 plus, and then it's a third of x minus d. And then the neighbour gets 8 plus a third of x minus d minus s. And these add up to make x. Maybe this is nicer. So now I've got 24 plus x minus d over 3 minus d over 3 minus d over s equals to x. And this is 0. So 24 minus 2d over 3 minus d over 5 equals 0. So that's 24 minus 10d over 15 minus 3d over 15 equals 0. That's minus 13. So we've got 13d over 15 equals to 24. That's also wrong. Oh, that's s over 5. Oh, it's not 5. It's s over 3. Okay. Third x. So we've still got 24 minus 2d over 3 minus s over 3 equals 0. So 2d over 3 plus s over 3 equals to 24. So 2d plus s equals to 72. Oh my god, 9 minutes. 2d plus s equals 72. I mean, I guess I could work that out just with this. So that's 16 plus 2x over 3 plus 8 plus x over 3 minus d over 3 equals to 72. So 24, and I take the 24 away, that's 48. And now I've got 3x over x minus d over 3 equals 48. X equals 48 minus d over 3. But d is 8 plus x over 3. So 3x, no. I wonder how you meant to do this, because it's absolutely not this horrendous way. Got these simultaneous equations. So 3d minus 24 equals to x. So 3d, wait, no, I want to find what x is. Okay, so let's put this over here. X equals 48 minus 8 over 3 plus x over 9. So 8x over 9 equals 48 minus 8 over 3. What? 8x equals 480, 432 minus 24. 8x equals 408. X equals to 51. So the answer is 6. Yes, that was disgusting. I hated that. That wasn't even fun. Now the issue is, I would be done at 54 minutes, but I haven't done question silly 13. So I've got A, B, B, A plus B, B. Oh my god, I found my mistake. I found my mistake. I found my mistake already. Instantly found my mistake. A squared equals 20. A plus 2B squared equals to 64. Instant finding mistake. Instant. And we want 2B plus, what we want is 2A plus 4B. Well, this is going to give me A squared plus 4AB plus 4B squared equals to 64. Wait a minute. A plus 2B equals 8. 2A plus 4B equals 16. It was so easy. It was so easy. And like that, I'm done. Let's stop the clock. That was a bit cursed. Control. Pause. Now we're done. Speedruns. Not actually speedy at all. Oh god, loads of disasters in there. The last one. Sorry, had a slight technical glitch, but we're good, I think. Yeah. Okay. Honestly, yeah, it was okay. Nothing that I was like, whoa. Maybe question 16. I like that. I like the counting one. That was kind of fun. 22 is a classic. 23 was kind of cool. 24 blew my mind. 25 kind of blew my mind, but also because this is the worst working out I've ever seen for anything. This is also horrendous. There must be a much more elegant way that I don't know, but I'm going to pause the video there. Thank you so much for watching. Maybe you got to the end. You probably didn't. 55 minutes, 23 seconds to get 100%. Hopefully I got 100%. Probably tweak something. That's not even fast. But it's fine. I had fun. Hope you had fun. See you in the next one.